Hello everyone. Uh, Welcome to Microcontroller class. Uh, I'm Lê Đức Hạnh, and this slide shows my contact and research. So during the courses, if you have any questions, so please feel free to email me to ask the questions. So about the documents, so I post all the documents on my website, my private website, so you can access the website with this address here. Okay, and you choose the courses, here, and then you choose the microcontroller class, and you will have the slide, all the slide for the courses. And also this website will show some recent research about a reference. We have the main reference is so in the number 1 and number 2 here. Besides, I myself write a book about the microcontroller, about our courses. This is for the reference, and you can buy it at the B10 building, B10 building, and it's very cheap, just 26,000 VND. So I hope everyone can buy it. And about the syllabus, our controller class, microcontroller class, consists of about 5 modules. First is I/O, input and output applications. Module 2 is about analog to digital conversion. You already get familiar with the module 2 in the previous course, something like electrical and electronic equipments for machinery, or autonomous technology. Yeah. And the module 3 is about the timer, and module 4 is about the PWM, not BMW, right? PWM. This is for the motor control, and module 5 is about the communication between two microcontroller, or from one microcontroller to our PC, something like that. And this is some protocol we will study. It is RS-232 and RS-4, A5, and yeah. Uh, First of all, we will discuss about the microcontroller. Okay, and this is the brief review of the definition of the microcontroller. And first here we can see that we have some notations. This is microprocessor, and this is microcontroller. So what is the difference? What are the difference between microprocessor and microcontroller? First of all is this is the very well-known flowchart, right? You already study in the autonomous technology courses, and our microcontroller it will be here in this block, right? It will control the actuator and receive the signal from the sensor, right? So this is the position of our microcontroller here. So let's define what is a microcontroller. So I think that's all you already use microcontroller, but you don't know about it. Example, when you use the cell phones, or the PC, yeah, or electronic clock, right? So it's empiric microcontroller inside. Yeah. So regularly speaking, right, a device that has a button and a digital display. So this has a programmable microcontroller here, and microcontroller is a designed for read the input device such as a button, sensor, right? I already discussed, and also process the data, right? Analyze the data, right? And then control the actuator, example light, display, motor, or speaker, right? And can you name other device that have the embedded control inside? Yeah, okay. So previously I already said about microprocessor and microcontroller, right? So what are the difference between them? So microprocessor is the brand of the computer science, right? We can say that the microprocessor is must communicate with the input or the output device, right? If only it, they cannot work. Right? They must have some other device connect with it. Example the keyboard, the RAM, right? So but the microcontroller have different. They have the everything built inside. That means a microcontroller will consist of one microprocessor and other device inside. Yeah, it include the memory, the input and output ports, the timer, the serial and parallel, and also the AD, analog to digital converter. So this is the picture about the microprocessor and microcontroller. Here you can see that this is the microprocessor, right? Right. Just only it's called microprocessor, but when it's in here, right? And then all the external device, right? Install inside, install beside, right? And then they package, and then empower it into one, like this. So this is the microcontroller. So this is microcontroller. Okay. And the microcontroller, they have different size. In the slide you can see that some microcontroller is big, right? It's big, and small, right? And also it's smaller, right? And then smaller, and then super small, right? And then super small. Okay, so they have different size. And why they have different size? Okay, in the next lecture I will discuss. And when we discuss about one microcontroller or read data sheet of a microcontroller, we must read carefully about some specification. First is ALU, right? ALU is respond for doing mathematics, okay, adding, subtracting, shifting bit, or perform logical operations. And also the second is the RAM. It is random access memory, right? And then the EPROM, right? And the EPROM, right? And then the IO, right? Input and output. We will discuss how many input and how many outputs, right? It will consist of how many device we can control, right? And then the timers, that means okay, how many timer we can use inside, uh, and AD, and then the AD converter, how many channel we can use or to read the sensor or to control a device, analog device, and then the this is the clock, this is the speed, right, the speed of the microcontroller, right. We will know that the speed of the microprocessor is very high, right. And then the module, and then the communication module, right. And then the interrupt controller, right, interrupt controller. So we will discuss everything in these courses. And something, this is the basic block of a microcontroller. It consists CPU, this is ALU here, right, ALU here, and then this will connect with the external component, right, communicate with external component. This is, we call this is the bus, right, bus. All right, bus, what is the bus? Bus is the electrical wire, right. So this is the basic block, right. This is, you can see that this we can communicate two directions, right. Right, two directions. This is very important, and this is the block of our big, right. Inside you can see that it consists of everything we will study. Example, this is the timer, this is the communications, and this is the I/O port, right. From this block we can see that we have the 5 ports, so the capability of control the external device is very high, right. And then we have the memory, this is AK, right, and we have the EEPROM here, right, and we have the speed here. This is the oscillator, this is the speed. This is it will work at 20 megahertz or higher, Okay, so this is the first part.